So in this video, we're going to have a look at writing total ionic equations. And then we're going to have a look at something else called net ionic equations. So we're starting with total ionic equations. The first thing that we're going to do is to write out our actual reaction. So we're going to do this example with a double displacement. Reaction. So the first compounds that I'm going to use is going to be sodium sulfide, and then I'm going to react that with iron to sulfate and produce my products. So with this double displacement reaction, our products are going to be sodium sulfate and iron to sulfide. So once I know what my reaction is, I want to write out the formulas for everything in my reaction. So my sodium sulfide formula is Na2S. Iron 2 sulfate is going to have a formula of FeSO4. And they're going to react to produce our sodium sulfate. And the formula there is Na2SO4. And then our iron 2 sulfide will end up being FeS. Okay. One of the other things that I want to do is to make sure that this reaction is balanced. So I just want to double check here. And it actually looks good. So we have 2 sodiums on either side. We have 1 iron on either side, 2 sulfurs on either side, and 4 oxygens. So it's an already balanced reaction. Okay, so when we're looking at ionic compounds, the one thing that we also want to review is what state each of these are going to be in. So we're going to look at our solubility table, and our sodium sulfide is going to be aqueous. It does dissolve in water. Our iron 2 sulfate also is aqueous. It dissolves in water. And then our sodium sulfate also is going to dissolve in water. Okay, so that's going to be aqueous. But the iron 2 sulfide is actually not aqueous. So it's going to be solid. It's insoluble in water. Okay, so what I want to do is I want to take apart my ionic compounds because I want to write them as they are actually going to appear in water. So I'm going to start with my sodium sulfide. So really this is 2 sodium ions that are aqueous and a sulfur ion that is aqueous. Okay. Then my iron 2 sulfate, because it dissolves in water, it'll come apart and form its ions. So that's really an Fe2+, that's aqueous, and an SO4 2-, that's also aqueous. And then I've got my reaction arrow, and my sodium sulfate is going to come apart in that same way. So I'm going to end up with 2 Na+ that are aqueous, and a sulfate. Got a 2- charge and is aqueous. But the last compound that we have here, the iron 2 sulfide, is a solid. So it's not going to dissolve in the water and form ions. It's going to stay as a solid. So we're going to keep that together. And so what we have here as this whole reaction, this is our total. So that whole reaction is our total ionic equation. Okay, so the reason it's called a total ionic equation is because we've got a reaction equation and it's showing all of the ions, right? So the total ions that are involved in this reaction. Now, you'll notice a couple of things. We have 2 sodium ions on the left here and 2 sodium ions on the right. And so those are actually what we call spectator ions.